Okay, so what I've got here is the pump cover half of the fluid pump of a 4L60E. And the reason I'm showing you this is because this transmission had a broken 2/4 band and the 3/4 clutch pack was burned up pretty badly. A lot of people would just replace those parts, put it back together, and run it. Not a good idea, because without identifying why that happened in the first place, it's likely to just happen again. And so I'm going to show you exactly what's wrong with this transmission, or what I suspect is wrong anyway. I've cleaned this up, and I'm about to vacuum test it. So this valve here is the torque converter clutch valve. Then over here is the pressure regulator valve, and then down here is the boost valve. So there are 3 valves in this pump cover, and we're going to test to see if the torque converter clutch valve holds vacuum on this port right here, and also on this port right here. With this one, it's going to be with the valve in the outboard position, which is its resting position. You also have to cover this port right here with your finger in order to block it off so you can build vacuum when you test it. And then for this one right here, you just push in with your fingertip. Alright, and then with the valve stroked in the inboard position, your finger acts as a seal for that one. This section right here is going to allow you to test the boost valve assembly, and you have to put your finger over this hole, I believe, one of these two. You'll feel vacuum when you go to do this, so it'll be obvious which hole you need to cover. And then we're going to also test this port right here. Okay, and for this one, the pressure regulator valve has a little hole right there. What you have to do, and I'm not kidding, this is literally what the instructions say to do, you have to plug that hole with a pencil eraser or something equivalent in order to draw a good vacuum and see whether or not the valve is sealing in the bore. This assembly right here, specifically the pressure regulator valve and the boost valve, when these don't seal very well, it can cause the 3/4 clutch pack to burn up, and it can also cause the 2/4 band to break, and both of those things happen to this transmission, so I'm pretty sure I'm going to see weak values right here, and I'm expecting to see weak values here as well. So yeah, I'm going to test those real quick. I've got a Sonax vacuum tester, and it's connected to a vacuum pump. So the tester has this gasket, alright, and you use this to cover or to seal the parts that you're trying to test. And then you use this plate in conjunction with it to draw a vacuum. And so I'm going to draw a vacuum on all 4 of the points that I just talked about, and ideally you'd want to see between like 18 to 25 inches of vacuum. That would be pretty much factory. That's a good seal. Anything below 15, generally most people consider that to be a fail, so you'd need to either repair or replace the pump. If you saw values below 15 inches, and I'm expecting to see values well below 15 inches. So I'm going to go ahead and put this on here. Okay, I don't know how loud the vacuum pump is going to be, so I'm just going to test all 4 of these spots. Alright, and then after that I'll shut the vacuum pump off and I'll tell you what I found. But this is how you test them. So I'm going to start the pump now and test them. That's about 11, 10 and a half maybe, so that's not good. That's about the same, about 11. That's actually about 20. That's a little bit over 12. Alright, so I'm not sure if you could hear me over the vacuum pump or not, but the torque converter clutch valve, that was about 12 inches, so a little under 15. Definitely not what you want to see. This part though, that was actually about 20 to 21 inches, so that's a good seal right there. When the valve is stroked to the inboard position, that was sealing pretty good, but in the outboard position it's not. So the valve on this end is definitely worn in the bore. Boost sleeve, that was about 10 and a half or so, maybe 11. So that's definitely a fail, and the pressure regulator valve was also about 10 and a half, which is well below the 15 that you want to see as a minimum, and way below the 18 to 25. That's like top of the line, off the assembly line, factory floor values. So I pretty much expected that. Really, I expected these to be below 10, both the boost sleeve and the pressure regulator, but they're at about 10 and a half or so, maybe 11. And that's really weak, so I'm going to be ordering a replacement pressure regulator valve, boost sleeve assembly, and a replacement torque converter clutch valve. And hopefully that will bring the vacuum values up above 15, or at least to 15. Because I have no doubt that this is why the 2.4 band broke and why the 3.4 clutch pack is smoked. In fact, this is what the 3.4 clutch pack looks like. It's black, delaminated, not in good condition at all. It's absolutely destroyed, burned up, got very, very hot. And that is something that can easily be caused by this. It is the number one cause, I would say, of the 3.4 clutch burning up, is problems with line pressure, whether that be from the pump or in the valve body. And I'm going to do some vacuum testing on the valve body. I'm expecting to see some low values there as well. There's really quite a lot of wear on this pump cover, and normally, you'd probably want to send this to a machine shop and have it milled. But I think I'm just going to clean it up, maybe with some sandpaper or something, and that should be good. I don't think the pump cover is actually going to be a problem, but I'm definitely replacing both of these valves and the boost sleeve, and that should fix this transmission. I've already got a new 2.4 band, obviously new clutches and seals, a whole rebuild kit, new bonded pistons in the input drum, everything. And I believe that once I get these valves replaced, I should be able to get vacuum values above 15 inches of mercury. And I think that's going to make all the difference, because if I were to put this back together the way it is right now, I have no doubt that it would fail probably before ever reaching 100,000 miles, maybe even around like 50 or 60, if not less. So, it's important to understand not only what went wrong with your transmission, but why what went wrong happened in the first place. In this case, it's definitely a line pressure issue. And, a lot of people wouldn't even bother to check this kind of stuff. They'd just replace the damaged components and throw it back together. Don't do that. Actually investigate, figure out why it happened. That's what matters. Otherwise, it's going to happen again. So, I hope this was helpful. I guess I'll see you guys later.